let's start translating or transforming, not translating, but transforming some logarithmic equations and logarithmic functions. So we're going to start with the parent function, which is f of x equals the log of x. Now, one quick reminder, and this has really nothing to do with the transformation piece of it, but I want to zoom in on this. Remember, this is the same thing as log base 10 to the x. Now, the reason I bring this up is if you were watching and looking at the videos from the first part when we were looking at 10 to the x, this is the inverse of 10 to the x, just to kind of get you aware of it. But mathematicians are lazy, and we assume if it just says log of 10, it's a base 10 that we're working with. All right, so problem number 7 here, we have basically a transformation. After the log of x, we've got a minus 3. So we've got the log of x on its own and then the minus 3. So what does that minus 3 do? This is going to be a vertical translation. And this is going to be down 3 units, okay? Now, before I get into graphing this, I'm going to add in the vertical asymptote that belongs with logarithmic functions. So when we are dealing with a logarithm function, there is a vertical asymptote right here on the y-axis that, and again, with every asymptote, you approach, wow, that looks horrible. Hold on a second. You approach the asymptote, but you never actually cross it or touch it in this case. Now, I know if I look at this graph, it looks like this just becomes a blue line that's the same as the y-axis. It's happening so fast that we can't really see that there is a space between the y-axis and the asymptote, or and our graph. Okay. So what's going to happen is I'm going to take all of these little red points here and I'm going to translate them down 3 units. All right. So every single one of them moves down 1, 2, 3. Let's see. Now these are going to get interesting because these are kind of between points. And so we want to be careful. I'll go ahead and come all the way over here to 10. So 1, 2, 3. Now everything else is going to be kind of in the middle here. All right, and then this last one is this one right here, which is basically halfway between, maybe a quarter of the way. So 1, 2, 3. Okay, so with logarithmic functions, we have very, very slow growth moving to the right here. And this is basically just going to drop off as we go towards the left. Remember, you can't cross your asymptote. You can only approach it. So let's get that curve going that way. That looks kind of horrible. Let me try that again. See if I can keep the line a little bit smoother. That looks a little bit better. And if we then come down here, again, the y-axis, it's going to look pretty much like you are on the y-axis there. And I get why that happens, but again, you're not actually on it. You just keep approaching it further and further. All right, let's talk domain here. The domain for a logarithmic function, the normal one, is to go from 0 to infinity. Now, you can't actually touch the x-axis. Nope, I said that wrong. You can't touch the y-axis. So you never actually use x is equal to 0. So you're going to use parentheses here, not a bracket. Range. Range is everything. It's negative infinity to infinity. This is very clearly dropping down to negative infinity. This is very, very slow growth, but it is still growth. So just be aware of that. All right, asymptote, we talked about it. It's this vertical line right here on the y-axis. Because we translated down, it didn't move. That's going to be x is equal to 0. And intercept, let's see, I'm going to go ahead and say for the y-intercept, there is none. For the x-intercept, you could put it in your No, you actually couldn't. I'm trying to think in my head. I was like, no, you can't put 0 in for x. Well, that would have been your y-intercept anyway. And we don't have a method to solve these problems yet. So for a y-intercept, absolutely none. All right, I'm going to go ahead and slide on over to problem number 8. Now, 8 and 7 look kind of similar because both of them have, oh, look, a -3 in it. The difference is this transformation, this -3 is attached to x. Because it's attached to x directly, like inside the parentheses, those are your horizontal changes. So this is a horizontal translation. And this is going to be, we've talked about this multiple times. Yes, I know it says -3, but this is actually going to be moving you to the right 3 units. Okay, and that's the only translation we have or transformation we have. So I'm actually going to start with the asymptote. Okay, so if I look at the normal asymptote would be right here on the y-axis, kind of darkening it up a little bit. All right, I don't want to make it too dark. And basically, I'm going to take it and loop it, and it's going to move to the right 1, 2, 3 units. Okay, so now I know that's where my new asymptote is, and basically every one of these red points, I'm just going to slide to the right 3 spaces. So let's go ahead. I'll do that in purple, I guess. All right, so 1, 2, this one's really close here. 1, 2, 3, 1, 2, 3. I know this is kind of tedious, and it's also 1, 2. There's not much change when you're looking at the x-axis. If you think about it, like between 1 here on the x-axis and 10 here on the x-axis, you've only gone from 0 to 1. Right? This is really gradual change here. So just be careful, do your best. And yes, I know this particular point here at 10 is going to shift off the graph completely. Don't worry about it. All right, so I'm going to shift through here or graph through those. And then this is going to graph on down. And it looks like I'm curving the wrong way. All right, so it's supposed to curve again towards the asymptote. It keeps approaching it, but it doesn't actually touch it. All right, domain here. Because we shifted to the right, we've actually shifted our domain to the right as well. So because it's now at, we've shifted to the right 3 spaces, our domain is going to be from 3 to infinity. The range didn't change, so -infinity to infinity. Because we shifted to the right, the asymptote has now become x equals 3. And your intercept, well, you still don't have a y-intercept here. All right, so none. Yes, I know I have an x-intercept. I'm not going to worry about that, though. So yeah, y-intercept here, none. X-intercept, I could read it off the graph if I needed to. All right, so that's if you have to actually do some translations and graph them. I'm going to go ahead and slide down to the next 4. Let's pick, I don't know, 2 of these. I'm going to go ahead and do 9, and I kind of like 12. Okay, so the original parent function is log base 2 of x. So the base 2 is not a change. That's no transformation. This is the parent function. We want to look at what's changing for the entire logarithm or what's changing for x. So I'm going to go ahead and slide in and zoom in on number 9 here. And there's a lot of transformations going on. I will probably run out of highlighter colors. All right, so we have a negative. We have a 1/2. We have a 3 here. We have a -1 here, and I did run out of highlighter colors, so let me go grab another one. And we have a -5 at the end. So if I look at everything, the stuff that is not highlighted, log base 2 of x, everything else is some kind of transformation. All right, now I'm just going to start working my way from left to right. So I'm going to start with the negative, do the 1/2, the 3, the -1, and then the +5. All right, so what happens with a negative in front of the entire logarithm? That is a reflection over the x axis. All right, so that's the first one. Let's see. Second thing, we've got a 1/2 in front of the logarithm. So that is a vertical compression by 1/2. All right, so that's 2 down. Now I've got a 3 sitting in front of this x. So this is actually being multiplied with the x as part of the argument of the logarithm. So this 3, and these are going to get strange for the next 2 of them, but that 3 is a horizontal. It is also a compression, but it is a compression by the reciprocal of 3, so it's going to be a compression by 1/3. All right, horizontal, remember, are kind of those goofy backwards things. So just be careful that you remember those for the horizontals. And speaking of horizontal, right, x minus 1 inside the parentheses here, that's going to be a horizontal translation. And that's going to be to the right 1 unit. And last but not least, we've got that +5 at the end. That one's pretty straightforward. It is a vertical. That is horrible. Hold on a second. There we go. Vertical translation. And vertical translations are pretty straightforward. Because it's positive, it's going to be up 5 units. All right, so that's the 5 transformations in problem number 9. And yes, there's lots of them there. All right, let's take a look at problem number 12 and see how many we get for there. One less, I think. All right, so negative sign, 8. The x has a +3 attached to it, and we've got a -4 at the end. So we've got 4 transformations. Let's go ahead and identify them. The minus sign here is the same as the minus sign in the first problem. That is a reflection over the x-axis. If your x value was negative, that would be a reflection over the y-axis. All right. Let's see. The 8, this 8 right here is being multiplied times the logarithm, so that's going to be a vertical stretch. Oops. By 8. So we're going to make the graph 8 times further away from the x-axis. We've got x +3. That's all in parentheses there in the argument. So that's going to be a horizontal translation. And I know it says +3, but that's going to be to the left 3 units. And last but not least, we've got this -4 sitting here at the end. So that's a vertical translation, and that's going to be down 4. All right, so we've done 2 problems on just listing the transformations. That's 9 and 12. And then we did 2 problems that had some graphing and then some key features. I'll go ahead and fill in 11 and 10 on the key. You can check your work against it. And as always, if you have any questions or concerns, please let me know.